Remember what 2 times will ruin a domain? Okay, what are the 2 times that the domain can get ruined? Correct? Very close. When we divide by 0, it'll mess the domain up. And if we take the square root of a negative, it'll mess the domain up. So those are our 2 main times where you're going to have a problem. So if I look at this first one, I have x squared. Is there any number that I can't just square? Like if I put a negative 5 in. Negative 5 squared gives you 25, right? There's nothing I can put in that will ruin this problem and make it not work. So because of that, that tells me that my domain here would be from negative infinity to infinity. Yes, ma'am. Yeah, if there's no restriction on the domain that messes it up, then that's when you put infinity. All right, look at number 44. So I'm dividing now, so that should give me a red flag. What number am I not allowed to divide by? To divide by 0. So if I put a 0 in here, I can't divide by that. So that's the only one that won't work. I can divide by negatives, I can divide by positives. So the only time it doesn't work is 0. So for your domain, you could put x is not equal to 0. That's the only restriction on that domain. So that tells us that it would be every other number works, but whenever you put the equal sign with the slash, that means not equal to. So it says the domain is everything except when x equals 0, or x cannot be equal to 0. Everyone good with that one? All right. If we look at number 46, now we have a square root. What does the square root mean? What's going to restrict that one? Exactly. If we try to take the square root of a negative, that won't work. So for this one, my domain, if I put a negative 1 in, that's going to mess it up. If I put a negative 0.01 in, that's going to mess it up. The smallest number I can take the square root of is 0. So you could either put the domain is from 0 to infinity. I'm not even going to make you stick to this interval notation. If you just said the domain was x greater than or equal to 0, I'm fine with that as well. As long as we're saying x cannot be negative. All right. Looking at number 48 now. This one has the square root, so we automatically think it can't be what? Well, we can't take the square root of a 0. What can't we take the square root of? Correct. We can't take the square root of a negative. So because we can't take the square root of a negative, that means that we think we automatically have a domain that's restricted where x has to be greater than or equal to 0. However, because this one has a squared under the square root, what happens when I square a number? Right, so if it's a negative, it would automatically become positive, and that negative would disappear. So, because of that, that tells me that my domain is from negative infinity to infinity. So that's, yes ma'am. Mm-hmm. Good question. You can tell if it's a number in an infinity if we put this restriction on it where it can't go below 0. So since it can't go below 0, I can't think of any negative numbers. If I put a negative infinity in, that means that it could be any negative numbers and any positive numbers. This one includes all positive numbers, so that's why it goes to infinity, but no negative numbers, so it stops at 0. So this is like looking at it from the algebraic approach. However, we can also look at it from a different approach here. If I don't know, just by looking at it, whether it's going to go from infinity to negative infinity or whatever, I can graph these in Desmos, and it will help me to see it. So just by doing the graphing in Desmos, if I do SQRT, do square root, and then up x, you'll notice that my red line doesn't go into any of the negatives. That's because it stops at 0. If I do my SQRT of x plus 1 squared, you'll notice it goes on forever in both directions, going this way and this way, which tells you it's negative infinity to infinity. For ones where it's going to give you like the dividing by 0 problem, those ones is going to be like 1 over x to the second. And you'll notice that for this one, it never actually touches 0. It gets closer and closer to 0. And it might look like it's touching, but it never actually does. So it creates this asymptote, which means it's just a line where it gets closer and closer to, but never touches. And so when you see them look like this, or like this, that's going to be a dividing by 0. And whatever it's getting closer and closer to, that's the number that won't work. Make sense? Okay. All right. Let's look at some of the piecewise functions then. Let's jump to, we'll say 59. Well, let's do 57 first. We'll do 57. 57 is a greatest integer function, which means that I'm doing parts A through E here. And if I'm doing the greatest integer function, that means that it's going to be the integer that's smaller than the number, and an integer just means a whole number. So it's the greatest integer that's smaller than the number, if the number is not an integer already. So if I plug 0 into this function, zero is a whole number. So my answer would be 0. If I plug in 1.6 to this function, then what's the biggest whole number that's smaller than 1.6? Yep, that's your answer. Part C, f of negative 2.3. So what's the biggest whole number that's smaller than negative 2.3. Negative 3. With greatest integer functions, it helps to think of the number line. I'm looking for the one that's smaller than it. So if negative 2.3 is here, negative 2 is here, so that would be bigger. Negative 3 is back here. And then part D, if I did 5 minus 2 pi, that would give me like f of negative 1.4 something, 1.6 something. So then I would just look at what is negative 1.6. That's going to go backwards to negative 2. And then I'm not going to have you do part E for these. I just want to see if you can plug it into the proper function. All right, 59 is another one. Piecewise functions people always struggle with for some reason. So remember that when I look at piecewise functions, I'm trying to figure out which piece do I put it in. So I only put it in the top one if the number is less than 2, and I put it in the bottom equation if the number is between 2 and 20. So what would I plug 0 in? Which equation, top or bottom? Right, goes in the top equation. So now everywhere I see an x in the top, I just put a 0. 0 squared plus 2 times 0. That's 0 plus 0, which is 0. For B, it's 1.6. Does that go in the top or bottom? Right, goes in the top. Matter of fact, for whatever reason, all of these go into the top, just because they're all going to be less than 2. So you just plug it in. 1.6 squared plus 2 times 1.6. And that gives you 5.76. So those ones aren't too bad. Let's do 58 just because that gives us a different type. So if x is less than 0, it's negative x, and it's x if x is greater than or equal to 0. So if I put 0 in for 58, which one does it go into, the top or the bottom? Goes into the bottom. So that just makes this 0. What about B? Bottom. Yep. So it's just going to be 1.6. What about C? C goes into the top. It's negative 2.3. So this would be a negative of a negative 2.3. So that would make it a positive 2.3. And then the last one. First I solved that 5 minus 2 pi out. I guess I should actually do that, huh? 5 minus 2. It's negative 1.28. I was way off my negative 1.6 earlier. Nobody's perfect, not even me. But where would a negative 1.28 go in? that goes into the top, and it's a negative of a negative 1.28. So that would make it positive. You like the piecewise? A lot of people don't, and I don't know why. I just